For assignment 52, it's basically a collection of all the exponent rules that we have learned since we started this unit. Remember, adding and subtracting monomials, we're combining like terms. Everything stays just like they are. So 9x squared minus, 9x squared y minus 10x squared y would be negative 1x squared y. If I was asked to subtract 6w from 8w, that's 8w minus 6w. If I'm subtracting 6w from 8w, I would get 2w. The product rule. Product rule says when you're multiplying, you add the two exponents. So h squared times h to the 6th would be h to the 8th. If we have coefficients, it's a multiplication problem, so we multiply the coefficients. We keep the variables and we add the exponents. 2 plus 3 make 5. B to the first and B to the first make B to the second. If it's a power rule, this is the one where you have the parentheses and you have the exponent right outside it. So you're going to multiply the exponents. So here, this would give you x to the 2 times 3 would be 6. Okay, and here, if it's some kind of a mixed up problem where you got to do a few things, you're going to take the coefficient to this power, remember, so it would be negative 2 to the second power. M to the 5 times 2 is 10, and then times m to the third. Well, negative 2 to the second power would be 4, and m to the 10th times m to the third, I'm just going to add those exponents and get 4m to the 13th. Quotient rule, when you're dividing, you subtract the exponents. Yep. So if you have a number like this, and I can't divide 27 divided by 42, I'm going to focus on this and just treat that like a fraction that I can reduce. These are both divisible by 3. So 27 divided by 3 would be 9, and 42 divided by 3 would be 14. Okay, and then 5, take away 1. Remember, I'm subtracting the exponents, would be x to the 4th. So another way to write that is 9/14 x to the 4th. Or you could write it this way, either way. So here's a mixed problem. We got a couple things going on. Y to the second times y to the second. Y to the second. 2 times 2 would be 4. Over y to the 4th. Well, this is now I'm subtracting the exponents. 4 take away 4 is 0. And anything to the 0 power, remember, equals 1. The number 1, not 0. Negative exponent rule. This is the same as 1 over x to the a, the reciprocal. So if you have a problem like this, be careful. Negative 5 is a coefficient, it's not an exponent. So the only thing I need to fix is just the x. So the negative 5 is going to stay up top, and the x to the negative 2 is going to be x to the positive 2 on the bottom. In this problem, treat this as a fraction. It's not 2. 8 over 4 would be 2. This is 4 over 8, which is 1 over 2. K to the 2 minus 5 is negative 3. Well, now this guy needs to be fixed. So the 1 can stay, the 2 can stay. K to the negative 3 would go to the bottom as k to the positive 3. So you'd have 1 over 2, k to the positive 3. The 0 exponent rule, anything to the 0 power is equal to 1. But be careful. This is, the whole thing is not being taken to the 0 power, just this guy. So just that guy is equal to 1 because there's no parentheses. So this really means instead of 7 times x to the 0, it really means 7 times 1, which is 7. Here, power to a power, so I'm multiplying the exponents. We worked one just like this just a second ago. 8 minus 8 is 0, and anything to the 0 power is equal to 1. So let me throw another problem in like this one. What if I had 28x to the 7th over 4x? Well, these coefficients would divide down to 7, and I would simply subtract the exponents and get 7x to the 6th. Okay. So in this lesson, you're going to see this exponent rules maze. This is for extra credit. So you're going to start here and you're going to simplify this. And if the answer is this way, then you go here. And then you would simplify this problem and then go whichever way it tells you to go. If you start here and this is your answer, then go this way. Go whichever way, whatever the answer is to this problem, that's the way you're going to go. And you would just shade in, color in whichever route you're going, okay, to the next problem, until you get to the end. Okay, and it has to be done correctly to get the extra credit.